let's talk through what we got going on here. So today we're going to do FRQ practice, and it is from 2016. And it is question number 1. So for those of you here in the room, you've got the paper copy, and I have the scoring guides here for you for when you're done. And then for those of you that are in the Zoom, it's on Access, and I'll show you here in just a couple minutes where you'll find that on Access. But I also want to highlight there is a new assignment. I did decide to go ahead and have you work on the positive physics assignment for Unit 13 on energy. And so like you did on the previous ones, it'll be the assessment. Your grade will be the average. So we'll just stick with the same system. It does have more questions. So this last one I had 6. I think this one has 20. So there are more, but there are some vocab, and there are some, they're not all math oriented. But I want to show you a couple things about positive physics that, based on the questions I'm receiving, I think a few of you may not have picked up on. So let's first go to positive physics, and then I'll show you where that FRQ is for those that need that virtually as opposed to on paper. All right, so on Access, you guys on Zoom can see Access now, right? All right, good. So on the calendar, you can see this next Unit 13 assessment's due next Thursday for you guys. So today is the 17th, it's due on the 25th. And when you go to positive physics, this is the one we just had, Unit 16. And I think all of you by now know that these videos can be helpful. But for instance, on these 3 sections, there were 2 questions in the video. I think for each one of the videos, it just addressed one. And so if you happen to get the other one, then these videos didn't address it. But I mentioned this a long time ago, but I haven't reminded you in a while. A lot of the pages have extra videos down here. And I think for each of these categories, the one that was missing is explained down here. And so if you've missed that connection or that extra resource, don't just look at these videos along the edge, also look at these, and you only see them in the work section. If you're on the assessment tab, you don't see these cameras, you only see these. So if you want to see these cameras, you got to go to the work section to see those. So a couple little details. And then there's still a couple of students that are not correcting it. Like they're getting a score and then their correction score is just the same percent. So possibly that they just weren't sure how to correct it, so they just couldn't. But remember that you do earn the average between your original and your finalized percentages. So if you click finalize when you're done with the quiz and then go back and change your answers, you can earn a better score. So just a reminder about that as well. So now we'll be going to Unit 13. And you can see Unit 13 is quite a bit bigger in terms of the number of questions. Takes a minute here to load for some reason today. There we go. There's quite a few more sections to go through. This is the work view right now. That's you can see a lot of videos. And then you can see down here, there's a couple extras to help with. Okay. All right. So, and if you see this section, there's a lot of practice. But if you go to the assessment, you can see this shows how many for each section there are. So there's none on the review or inquiry part. And so you can kind of see the range here. All right. Yeah, everybody likes the vocab questions. Those are quick.
I love that. It's like, oh no, I have 20 more problems, but half of them are vocab. So it'll take a minute.
Yeah, so that's just a quick overview reminding you of a few things about positive physics. Since this one's a little bit bigger in terms of number of questions. So not going to have any other outside of class assignments between now and next Thursday, but strongly recommend don't wait till next Wednesday night. It's a little bit longer. So plug away at it, work at it little by little, keep saving your work. Don't forget to, when you're working on the assessment, don't forget to save your work. So as you're going through, like if you answer this first question, make sure you click check answers. Finalizes after you complete all of them, but check answers saves your work. So if you don't check answers and you just go on, then when you come back, you're gonna have to do it again. And if it's a number-based problem, a lot of times it'll change the number. So make sure you're clicking check answers when you're done with that question. All right. And then you can do a little bit today, a little the next day, a little the next day, kind of work your way through it. You can go through and get all the ones done that you know right off the bat. And then the ones you don't know, go back and find the video, figure it out, come back. But make sure you click check your answers on the ones you're finished with. All right, I think that's pretty good for positive physics. Couple reminders. Today, for those of you that need this FRQ in digital form, go to topics, and it's the first topic here, AP exam resources. And then over here on the right, you see all these dated FRQs, so 2015, 16, 17. I don't have the 2020 because it was a strange year. They drastically modified the test. So, but these are the typical ones that we're going to expect the same format this year for, at least for the paper and pencil one on May 5th. And so these are all the examples with the scoring guides. When you open up the 2016, that's the one you want. I would just open up this first and then the scoring guide when we're ready later. You should see this question, but I do want to notice or highlight, this is what it will look like on the paper pencil version. You'll have a cover page. And I mean, the graphic design may be slightly different or whatever, but it's going to have the same basic idea. There's going to be a cover page, and then that flows into your formula sheets. So you've got both pages of your formula sheets, and then it gets to the actual FRQs. And here you can see it says there's 5 questions, total of 90 minutes to answer all 5. And then here it says directions. Questions 1, 4, and 5 are short free response questions that require about 13 minutes each to answer, worth 7 points apiece. Questions 2 and 3 are long free response questions that require about 25 minutes each to answer and are worth 12 points each. Show your work for each part in the space provided after that part. And so here you can see question 1, 7 points, suggested time 13 minutes. So that's the question I want you to answer today, question 1. It does go on to the next page, so make sure you do all parts A, B, and C. For you at the paper version, it's just front and back. And I'm going to give you 13 minutes. Okay, it says 13 minutes, so once we're all set, I'll start a timer. You get 13 minutes. See if you can answer all of it. Answer it directly on the paper if you're doing paper version. If you're doing digital version, just answer it on notebook paper. After 13 minutes, I'll tell you, okay, time's up. Now get out the scoring guide for you in the classroom. At that point, you can pick up the scoring guide, so I'll just go ahead and put those over, but wait till the 13 minutes is up. I want you to really try to get used to that timing. So after that, then you can grab the scoring guide. And then for you online, after the 13 minutes, then you can open up the online version. So it is 9:39. We'll go to 9:52, 13 minutes. You can use a calculator. Obviously, you can use the AP formula list. Good luck. All right, so let's quickly just have a conversation about the rubric, give you a chance to ask some questions if you have some. First off though, what is your gut reaction first now that you've seen the question, you've seen the rubric? If you think if you rated this was a really hard one, show me a thumbs up for like this was high difficulty. If you think it was really easy, thumbs down for low difficulty. If you think it was kind of middle of the road, sideways thumb. So what do you think? High difficulty, low difficulty, or kind of average? Okay, mostly average, couple lows. Okay. I would say if I were grading this on a scale of 1 to 5 in terms of difficulty, I would probably give it about a 2, where 5 is the most difficult and 1's the easiest. I think it's kind of on the easier side of things, but it's not simple. I've seen a few that are easier, but I've definitely seen a lot that are harder. So I just want to give you that scale in the background, not to try to discourage you or scare you or anything, just want you to be fully aware. And we'll be practicing these more and more. So the more of them you see, the more practice you get, you start to realize, oh, wow, that was a lot harder. And sometimes it's like this one, it's fresh in your mind. We just finished the unit on rotation. We're in the midst of the unit on energy. And so there's quite a bit here that's kind of fresh in your mind, whereas something that we haven't talked about in a while could be harder that way too. For part 1, asking you to draw the free body diagram, I just want you to recognize that you cannot earn partial points. So the first point, you would have to have both aspects correct. You would have to have the weight force going straight down, and it would have to originate from the center of the wheel. If either aspect was not correct, you wouldn't earn that point. Now you could label it MG like they have, or you could label it FG, but it has to start from the center of the wheel and point straight down to earn that first point.
Is FW all right?
FW probably. If you're going to use anything that's sort of not traditional, that you haven't seen a lot on worksheets and in our book, I would make a little key off to the side. Like
Okay.
FW equals the weight force due to gravity, just make a little key so they know exactly. Yeah, Kyle?
Can I just run to the bathroom real quick?
Yeah. And then for the second point, you have to have both the friction force and the normal force, and they both have to be drawn correctly. So they both need to originate from the point of contact with the wheel and the ramp, but the force of friction needs to go up the ramp and the normal force needs to be perpendicular. So if any aspect of either one is wrong, you don't get that point. So that, like I said, there's no partial, you can't get a half a point or a quarter point. It's either all or nothing. And that one requires 4 things to be true. You got the right 2 forces and they're drawn correctly. Any questions on 1A, or I guess AI, 1AI? Probably that was one of the easier parts of this question because we've done a ton of free body diagrams, but those little details matter. You might not have thought, oh, it needs to go from the center of the wheel, for instance. And if you didn't draw it from the center of the wheel, you automatically lose the point. And it isn't really a free body diagram, it's a force diagram because they're asking you to draw it from where it originates, not from like a dot representing the whole wheel. So it's slightly different. All right, for part AII, the force that causes angular velocity increase or angular acceleration is the friction force. So you have to have first that it is the friction force and then a rational explanation for why to get that point. If you don't say friction force, even if your rationale fits what you said, you can't get the point. And if you say friction force, but your rationale isn't clear, you don't get the point. So again, it's all or nothing. The rationale could be that the only force that has a perpendicular component to the point of contact and would cause a rotation in the wheel is friction. So you can explain it that way. They even said in the explanation of the question, there is enough static friction so that the wheel rolls. So you can kind of refer back to that. It was stated the static friction is sufficient to cause the wheel to roll. So the friction is the force that creates that acceleration. You can also use the chain of events like they've described here, and I think that's kind of a creative solution, that it all sort of is based on the fact that there's a gravitational weight. The weight of the wheel has a y component that matches the normal force, and the normal force means that there would be a friction force because it's mu Fn as long as there's friction existing. So it kind of chains together like they've explained. So somehow you have to say it's a friction force, somehow you have to indicate that how you know that's true. Any questions on A part 2? All right, if we move on to part B. On this one, we're asked to figure out, let me just reread the question here. For this ramp angle, the force of friction exerted on the wheel is less than the maximum possible static friction force, which is important. If it was not, then we would have some issues. So instead, the magnitude of the force of static friction exerted on the wheel is 40% of the magnitude of the force or force component directed opposite. Derive an expression using or in terms of m, theta, and physical constants. So you don't have to have m and theta and physical constants, but you can't have anything beyond that. So the first point is earned for recognizing the relationship between the x component of the weight force or the gravitational weight and the friction force, that those are the two that are parallel to the surface of the ramp. So quote unquote horizontal relative to the ramp. And one is up the ramp and one is down the ramp. So they would be kind of vector addition would be a subtraction step because they're going in opposite directions. So indicating that you understand those are the two forces and how they would relate is the first point. And then the second point, you can see there, they're using mg sine of theta because that would be finding the x component of the weight force. Because it's opposite, the side that's the x side is opposite the angle. So that's why we use sine. And it's based on the weight force, which is mg. And then because it said in the problem that the friction force didn't match that, but that the friction force was 40% of it, that's where the 0.4 comes from, saying that the friction force was 40% of that value. And so, or I said it's 40% of the force going in the opposite direction. And those are the two that we're looking at here. So then you can combine together, the M's cancel. And so even though in the directions it said in terms of M, theta, and constants, the M's cancel out. So again, you don't have to have the M, you just can't have anything in addition. So you can see they were focused on the M's, but they end up canceling out. And your final is A equals 0.6 G sine theta. So now they've only got G, which is a constant, sine, which is a function, not a variable, and theta, which was allowed. Any questions on part B? All right, for the last part, you hopefully knew which one would win because we just simulated that. And you hopefully were able to get the second part about energy because we broke that down. Here's kind of what we talked through, that for the wheel, in this case, it's a wheel. The other day it was a ball and it's all kinds of stuff, but today it's a wheel. That gravitational potential energy that they all start with splits into two kinds of kinetic energy, one that's translational to move it down the ramp, and one that's rotational to make it spin. But the block, because it's not rotating, turns all of that gravitational potential energy, which they have the same amount because they start from the same spot, all of it goes into the translational kinetic energy. So it's not dividing that original source of energy into two kinds of motion. So that's your explanation for the second part. But for the first part on forces, we didn't talk about that. We talked about inertia and we talked about energy. But for forces, hopefully the rationale here makes sense. If we think about the block, it has the X component bringing it down the ramp, but it said it's frictionless. So there is no opposing force. It only is the X component. However, for the wheel, there is a friction force. There has to be, otherwise it would slide down the ramp, not roll down the ramp. And they said that there was friction. So they both have the same X component down, but the wheel also has a friction resisting that, whereas the block doesn't. So that's how you can explain it with forces. So that adds another little wrinkle that we didn't talk about last time. Any questions about part C? All right. So when you're taking the actual exam, you're given the whole free response portion. You don't have to start with question one. You don't have to do them in order. If you finish question one and move on to question two, but then think of something, you can come back to question one, but you can't go back and forth between the multiple choice and the FRQ parts. So they'll give you the multiple choice first, and after that 90 minutes is up, you cannot go back and look at that multiple choice again. And then you get the FRQ part, and you can work on any of those FRQs in any order and spend as much time as you want. You could spend 85 minutes on one question and 5 on the other 4. I wouldn't recommend it, but you can do that. You have the full 90 minutes to do however you want to go through those 5 questions. And you can, move back and forth between them. You just can't move back to the multiple choice part. Any questions in general about the test format, or just bring up any other questions for me about the exam? All right.
We're gonna do more of these, right?
Yep.
Okay.
Yeah, I have all those online, so you can be practicing them on their own whenever you choose. But we'll continue to practice them. Every time we have a Wednesday together, we will. And then once we get back from spring break, there's really no big unit to cover. There's one sort of tangential concept that we're kind of covering already with springs and other things, but we'll maybe spend part of one day making sure you haven't missed it. And then we'll just be reviewing the rest of the time leading up to the exam. So we'll be doing a ton of them then. All right, so for those of you in the Zoom, if you have questions for me, you'll feel free to stick around, but if not, you can be dismissed and I'll see you tomorrow.
Thank you.
Thank you.